In the previous part of this video, we converted our hard-coded HTML into a TYPO3 plugin. We created custom database tables and defined the required fields for our data structure. After that, we configured the TCA, Table Configuration Array, to make these tables available and manageable in the TYPO3 backend. We made a record from the backend and also checked the data from the database table. Finally, we verified that the data was correctly stored and displayed in the backend, ensuring that everything was properly connected and working as expected. In this part, we will continue building on that setup and move further in our TYPO3 development process. If you want to see the previous video, you can find the link in the description. Now we will create the project model file and define all the properties inside it. These properties will match the fields we already defined in the database table using TCA. The model acts as a bridge between the database and our TYPO3 extension, allowing us to handle and access the data in a structured way within our code. Here we are defining properties inside our TYPO3 model class. These properties represent the fields that we already created in our database table using TCA. Each property in the model corresponds directly to a database column, such as title, description, date, or image. The model acts as a structured representation of our data, allowing TYPO3 to convert database records into PHP objects. This makes our code more organized, readable, and object-oriented instead of working directly with raw database arrays. For each property in the model, we use getter and setter methods. A setter method is used to assign or update the value of a property, while a getter method is used to retrieve or read the value. This approach gives us better control over how data is accessed and modified inside the application. Instead of directly changing variables, we go through methods, which helps maintain data integrity. It also follows object-oriented programming principles like encapsulation, making our code more secure, reusable, and easier to maintain in large projects. For handling images in TYPO3, we do not store image files directly inside the database or model. Instead, TYPO3 uses a system called File Abstraction Layer, also known as FAL. With FAL, images are managed separately in the file system and linked to database records using file references. In our model, we define a property that uses file reference instead of a simple string or path. This allows TYPO3 to handle images in a more flexible way. The same image can be reused in multiple records without duplication, and TYPO3 also takes care of file management, metadata, and storage locations automatically. This approach is more efficient, scalable, and follows TYPO3's best practices for media handling. Now we will talk about the namespace in our TYPO3 extension. A namespace is used in PHP to organize our classes and avoid name conflicts between different parts of the system or different extensions. It helps TYPO3 understand where each class belongs and how to load it correctly. Now we will create the project repository in our TYPO3 extension. The repository is responsible for handling all database operations related to our model. Instead of writing raw database queries, we use the repository to fetch, filter, and manage data in a clean and structured way. With the help of a repository, we can perform operations like fetching all records, getting a single record by ID, filtering data based on conditions, and creating custom queries if needed. TYPO3 automatically provides basic repository functions, but we can also extend it to add our own custom logic. Now we will create the project controller in our TYPO3 extension. It acts as the main bridge between the model, repository, and the view. It handles the application logic and decides what data should be fetched and what should be displayed on the frontend. The main purpose of the controller is to manage user requests and coordinate data flow. When a user opens a page, the controller receives the request, interacts with the repository to get data from the database, and then passes that data to the view, Fluid template, for display. This keeps our logic clean and separated. Now we will create the services.yaml file in our TYPO3 extension. This file is used to register our PHP classes as services so that TYPO3 can automatically detect and load them. It is an important part of the dependency injection system in TYPO3. The main purpose of services.yaml is to tell TYPO3 which classes are available in our extension and how they should be handled. Instead of manually instantiating classes using new, TYPO3 uses the service container to manage them automatically. This makes the code cleaner, more efficient, and easier to maintain. Now we will talk about the composer dump autoload command. This command is used to regenerate the composer autoloader files so that PHP can correctly find and load all classes in our TYPO3 project. We mistakenly write incorrect. The S of services should be capital. In the list action method, we use return $this-HTML response to send the final response from the controller to the browser. This tells TYPO3 that we want to render an HTML page as output for this action. First, the controller gets data from the repository. Then it assigns that data to the view. Finally, HTML response is called to render the template and send the final HTML output to the browser. And here we go, our plugin finally works. The rendering content is from list.html. In our TypoScript configuration, we have already defined the template path, so TYPO3 knows where to find this file and render it for the list action. Let's change the data in the list.html to check whether it is working correctly or not. Here data is changed. In TYPO3, when working with Extbase extensions, we often need to define a storage PID in TypoScript. The storage PID tells TYPO3 from which page records should be fetched. This is important because TYPO3 stores records on specific pages, and by default, Extbase only retrieves records from the configured storage location. Once the storage PID is defined, TYPO3 will fetch records only from that specific page. For example, if our project records are stored on a page with PID 25, TYPO3 will retrieve records from that page and ignore records stored elsewhere. We will copy the PID of the newly created storage folder and update our TypoScript configuration. By changing the storage PID, we are telling TYPO3 to fetch records from this specific folder instead of the root page. This ensures that our repository queries return the correct data. Once the new PID is configured in TypoScript, we will reload the frontend and verify that the records are still being displayed correctly. Even though the records have been moved to a different location, TYPO3 will continue to fetch and render them because the storage PID now points to the correct folder. And here we are creating a separate folder for our records. Here you can see the PID is 9. Now we will update our TypoScript and update our storage PID to 9. We see empty here because there is no record is there on the folder with PID 9. Now, we will create a record on that folder and let's see again here. And here we got our record and all the data we put in the record. In the next video we will see how to use the data in the list.html and also look for the category table. Don't forget to subscribe.